friends. Today we're going to be talking about using a full circle protractor. So go ahead and put that at the top of your page. Okay, so when we think about a full circle protractor, let's just go ahead and draw one real quick so we know what we're talking about. So just draw me a circle, just like that. And if you think about, we had 0 up here, right? What was at the 6 o'clock mark? How many degrees was that? 180 degrees, right? And then we've got 90 degrees over here. What would be over here? Yeah. Well, I've got each, if you remember, each one of our marks is 30 degrees. So you have 30, 60, 90, 180. So 270 is what you're saying would be over here. Yeah. Okay. So I'll make this look like an actual 0 right now. So each one of those, we've got 30, 60, to kind of fill in these other parts. 120, 150, 210, 240, 270, 300, and 330, right? Okay, so it's important that when we measure with a full circle protractor or any protractor, that we're measuring in a clockwise direction. Okay, so I want you to take your pencil and draw me a circle going clockwise, just like that, and label that clockwise. And I'll show you a little bit of what I mean when I think about clockwise. You might draw some arrows so that you're showing which direction it's going clockwise. Thinking about which direction the hands would move on a clock. So to start off with, I'm going to draw here an angle, and I want you to draw this angle with me because I want to review some of our terminology and our symbols when we think about angles. So I'm going to use this okay, so go ahead and draw an angle just like that. In this middle one here, let's go ahead and put some dots on here. Am I using line segments or rays to form this angle right here? What is it? Yeah.
Me?
Uh-huh. These line segments or rays that are joined here at this end point? They're line segments, that's right. So let's go ahead and change them to rays. Can either be line segments or rays, but I just want to review that vocabulary. If you remember, a ray goes on and forever and ever in one direction. We recognize that arrow right there, and on in one direction. So let's go ahead and label this A, B, C. So this is angle. If you remember, our symbol for angle looks kind of like an L right there. Angle A, B, C. Or I could have labeled this as long as my B, my vertex is in the middle and I'm not changing anything around. I could have also labeled it C, B, A. Okay, so I'm going to show you guys how to use your full circle protractor to measure this angle. Which direction am I going to be measuring? Clockwise, right? So in order for that to happen, I need to put this at 0. So that my numbers are getting larger. I'll show you what I mean. So with my full circle protractor, there is a dot here. It's in the center. Okay? I've got to put that on the vertex. But right now, I've got to find, since I'm going to be measuring this way, I need to start this one at 0 and figure out how many degrees it's moving up. So when I put this on the vertice, I need to move my full circle protractor so that that first angle right there is on the 0. Okay, I know that it's red below there, but here's 330 and here's 30. So this is 0. So then I count and I see 30, 60, 90, 120. And now I realize that my angle is, there's some hash marks that are small and hash marks that are larger. My larger ones here count for tens. So I've got 120 right here. So it's 130, 140, and this one right here is 150. So my angle right here is right over the 140. I know you can't see that real well, but my 0 is here, and I moved up to stopping at 140 degrees. So we can go ahead and label this angle as 140 degrees. Is that reasonable based off of what we know about angle measures? Yeah. Okay. A common mistake a lot of kids accidentally make when they're measuring angles is they might put the 0 on this one here, and then they're going counterclockwise. And watch what happens when I do that. If I put this at 0 and I accidentally am measuring counterclockwise, that puts this angle at 210, 230. Is that reasonable then? No, it's not. Okay, so I'm going to erase right here. You just need, you are welcome to close up your notebook and follow along with me just watching. Okay, I'm going to go ahead and use my straight edge this time to draw an angle. It looks like I should be measuring counterclockwise, but I'll show you how to get away with doing this correctly. I'm going to go ahead and put some endpoints on here so that I can label it. So let's go ahead and do, I don't know, FAC right here. Okay, so I'm looking for angle FAC, or what else could I name this angle? CAF. That's right, as long as my vertex here is in the center. So I want to measure clockwise. But a lot of kids, they'll start here and then they'll accidentally measure counterclockwise. We know that this is going to be less than 90 degrees, right? Because it's smaller than a right angle right there. So if I accidentally put my 0 on this one here, my vertex is in the center, then this measures and stops at 300 degrees. Is that reasonable? No, not at all. So I have to make sure that my angles are measuring clockwise. Okay, so I put my 0 on this one, and this time I stop at 60 degrees. Is that reasonable? Yes. So this one is 60 degrees. I can also measure a reflex angle, right? So if I want to measure that reflex angle, I want to be going this way. So that I need to make sure that I start this one at 0, and then I figure out how much around the circle. So my reflex angle, to make sure that I'm going clockwise and I'm looking all the way around, that reflex angle is 300. Is that reasonable? Yes. Yes. Because we know that a circle is 360 degrees. So if this angle on the inside here is 60, then this angle on the outside has to be 300, right? Because 300 plus 60 equals that 360. So that's another way to check yourself on whether your answer is reasonable. Okay? So friends, we will go back to our seats and practice with our full circle protractors. Go ahead and say goodbye. Bye.